is that you are, first of all, the first few problems, let me know if you have a question on them. We're just getting used to your identities. One thing that I want to make sure I say, that remind me to say it again when Bryn comes back, because when she comes back, she'll probably feel like since she's here, she doesn't have to watch the video. So hopefully Julia hears this at home. But now you'll start seeing the new things on quizzes, now that you have on your memo page and you're starting to learn them. And so on your quiz, if I say sine A over cosine A, and I just write that down, do you know what you should say for that? What's sine over cosine?
Tangent.
Good. So if you haven't learned that, be looking at your memo page, thinking about when you're doing your homework. So that would equal tangent A. You would just write that down. You're never going to have to like work anything like out on a memo page other than things like you already are, like sine of pi over 2 stuff, okay? If I say sine squared plus cosine squared,
1.
right, so do you see how I'll write part of it and you write the other part like you already do with 1 over cosine and 1 over sine. So those will start being on your memo quizzes. Also, I wanted to talk to you about what to do about things like sine of pi, cosine of pi over 2, cosine of pi. It's come up in my honors pre-cal class also to where it's starting to really bother me. And I noticed that's one reason I put it on your quiz today, to see where we are in here. You may not be tripped up by those, but you've got to be super good at these in calculus. Just like you should be getting to a place to where I know that you'll keep drawing your charts as kind of like a crutch, okay? But it would be a lot like, do y'all remember your multiplication tables?
Yeah.
And you would find 3 times 4 by going across and down. You know, I guess y'all had the same multiplication tables I did. And for a while you would find them on the table. Girls, we don't need to be doing that anymore. 3 times 4 is 12. I'd be really worried about you if you're like, can I have a chart of, you know, like, so you can look up your multiplication tables. It's called a memo page. It's not called a crutch page, okay? It's not called I hope you never memorize this page. It's a memo page to where I'm supposed to send you out knowing the sine of 5 pi over 3 is negative square root of 3 over 2. You should just know those things, okay? And so we're going to find some fun ways to make it faster that won't count against you, but maybe some kind of spelling bee type things like quiz bees where there's 5 against 5 and I've got a bag of M&Ms to give you or something, okay? But I've got to get you to where you really know that stuff off the top of your head, because I don't, and you'll see what we're about to get into, I don't slow down. When I get to sine of 5 pi over 6 is 1/2 and I'm moving on. Do you see those are supposed to be, you're supposed to know those. Bren, while you were gone, I said pretty soon on the memo quizzes I'll start putting the new stuff on there.
Oh.
And so I gave a couple of examples. Like here you would say tangent,
Yeah.
and here you'd say 1.
Yeah.
So it should be quick answers on your memo pages. And now I'm talking about how to find the quadrantal angles, because a lot of y'all realize, oh, I had to go to the IOU chart, and I'm so afraid you're depending on that, and it's such a shame. When I gave you the IOU chart, you probably don't remember, but I said, I don't use this, but I'm going to give it to you because it's kind of cute, okay? IOU, you know, 0, 1, 0, IOU, 0, blah, blah, blah. I really can't leave you there. You really don't need to be doing that. So let me show you how I do these. This I automatically know is 0, this one's 0, and this one's -1. Now granted, you could say, but I've done this for 9,000 years, so I better know what those are, okay? But that's really not the reason that I know what those are. I use this. Like Ava and I were talking about at the beginning of class. We know cosine is x over r and sine is y over r. Do y'all see the x-axis? And you see the y-axis, okay? A lot of classes, maybe Miss Arkan's class, uses what's called the unit circle. I shy away from that because the radius isn't always 1, okay? But if the radius was 5, this point out here would be 5, 0, right? What would this point up here be?
5 pi over 2.
Oh, I'm sorry, I'm just naming points
Oh.
right now. Do y'all see what, I'm just naming points. 1, 2, 3, 4, 5. -5, 0. Whoa, my pen's not working very well. -5, 0. And this one's 0, -5, okay? But I see like this red and green in my head, and I can do them super fast, and I really am going to encourage you to do that instead of your IOU chart. So everybody watch, okay? Like if I had an angle right here, do you see I have a Y, an X, and a radius? That's how we got all the Y over R, X over R stuff. And do you see my triangle here? What happens if I have a triangle here? I don't have a triangle, do I? So if I'm asked for the cosine of 0, it's 1. Here's 0. Isn't my X the same as my R? I don't care how big my circle is. Do y'all see what I mean? The X is as big as your R. Isn't that 5 and my radius is 5? And what is the sine of 0? In my head, I know I'm over here at 0. There is no Y value. Do y'all see I haven't gone anywhere yet? Y is 0. Do y'all see the common sense behind that? So in your quiz, for the cosine of pi over 2, I know that I've gone up here. Already on your quiz, you probably answered cosine is x over r. If you're going straight up, what's your x coordinate? There's not one, is there? To go to this point or this point or this point, aren't you just counting up the y-axis? You're not going anywhere across, are you? Aren't all of those dots 0, 1, 0, 2, 0, 3? Cosine's x over r, there is no x. I don't even have to barely memorize that, okay? If I'm right here, there's no x. Now, why is the cosine of pi so quickly to me -1? Do y'all see that's -5 over 5 or -1 over 1? Cosine's x over r. Y'all talked about the ways you've memorized it. And so I can see that my x is the same as my radius. Down here, what's the same as my radius? My y. So the sine of 270 is -1. The cosine of 270 is 0. I'd rather you like see that in your head, okay? Or if nothing else, we can use a unit circle or whatever size you want. But I'd almost rather see this on your quiz, where you would go, oh, here's a circle. This is 1, 0, 0, 1, -1, 0, 0, -1, okay? If I want the cosine of pi over 2, cosine's x over r is 0, I'm done. Tangent of pi over 2 is y over x. 0 on the bottom is undefined. Okay, do you see how much quicker that is than me depending on a chart that I can't even, if I use the chart, I would have to look it up. Hopefully you've done it enough to where you know it, but I don't think it's happened, okay? So if I want the cosine of pi, I go out here and I go, oh, cosine's x. If I want the sine of pi, do you see a 0? Hopefully you at least reach a point where you even see this in your head. Yeah. Okay, I hope that makes some sense. Now let's move to, what page was your homework on?
281.
All right, you'll have some more of these for homework tonight. 281, and let me show you how you should have done it, and then I'll let you ask questions if you have them. So after you got through, I'm on 381. After you got through the first few where you're just probably copying off your memo page, then that's just drill to get you started with the puzzle pieces, okay? Your memo page and a little bit of algebra are the puzzle pieces in the box to make the picture. So what do I mean by a little bit of algebra? I didn't have enough time to really clarify that the other day. So what algebra would you be expected to use? You would be expected to sometimes factor,
Cross multiplication.
never. Get a common denominator,
Foil.
possibly FOIL. And something that you haven't done in a while, but I can remind you of it, multiplied by the conjugate. Just real simple algebra, okay? And also I'll steer you in directions of where, I'm sorry, saying about something else. I was trying to think of a problem I want to make up for you. I'll steer you in the direction of how and when to use these things also, okay? Now, why I wouldn't allow cross multiplication, suppose I have this. Sine times cotangent equals cosine, okay? Some people want to go, oh, I'm going to divide both sides by sine. And cancel out and go, see, I proved it to you, Miss Lazari. Cotangent is cosine over sine. I will not allow that. The reason is, I already told you they were equal. not trying to get you to change it and prove that they're equal. I know they're equal. So if you start to divide and move and cross multiply, they're gonna still be equal. That's not what I'm trying to prove, because what have I said on the front end? These are equal. I know it's hard for you to see this, but if my calculus students have this, sine of A times cotangent of A, you don't have to know what that means at the back. If a bunch of girls walked in right now from my calc class and I said, oh, take that integral, they'd go, I can't. They cannot take that integral. They cannot do it. If you go to Harvard and you have a calculus teacher, your professor cannot take that integral. We don't know how to do it, okay? However, if I can simplify it the way that you're learning now, they would be able to do it. If they all walked into the room and this was on the board, I kind of wish a trail of them would walk in. If I said, what's the integral of this? They'd go, oh my gosh, if you learned how to do that, I mean, hopefully they would do what Bryn just said. If they look at this, they go, oh, sine, which you don't have to know yet. By the way, you don't have to know that the integral of cosine is sine, but when someone tells you that one day, you'll go, I've heard that before. Okay, I'm not teaching you all the integrals right now. But my point is, you're not there yet. And pre-cal is training ground to even know what in the world to change it into. Like, if you didn't have this part of this class, these moments with identities, then when you hit stuff like this, you'd be just lost as you could be. You go, I don't know what to do, okay? So what's happening right now, this is real important. When somebody gives you an identity in a pre-cal book, it's somebody in the know that knows one day that you're gonna face this. And they're just right now going in and telling you what you're gonna change it into. You're not trying to prove they're equal. You're trying to change the left-hand side into the right-hand side. Sometimes it will surprise you what's on the right-hand side. This time it looks way simpler. Sometimes it won't look that much simpler, but you just have to trust me that there's some things that we know how to work with calculus and some things we don't. So here's the deal that I said in class the other day. You don't mess with that side. You can't add something to it, you can't cross multiply, you can't divide. I've just said, here's the picture that I want to see. And let's put the pieces together to make that happen. So what can I change cotangent into?
Cosine.
Cosine over sine, so you're showing all your work. Then you cancel and you go, yeah, see, I showed you, Miss Lazari, I got it. So that one day, when this is not even sitting there, you have experience of what to change it into. Right now, if I just started giving you these and said, hey, simplify. Do y'all see it's really nice that somebody tells you what your goal is? That's all it is. I'm telling you, your job is not to prove equality. Your job is to change it into what I tell you to. Okay?
That's why I meant cross multiplication, because.
Okay,
Like the
cross
side of
multiply
the
means
line
over
times.
the equals.
Oh, okay.
Okay, so cross multiply means you were gonna do this. I think she means canceling out.
Yeah. Oh.
Okay? All right, so I'm sorry, I made that such a lecture, but it's real important, okay? Because it can be frustrating if you don't really hear me and you feel like you're working them right, or you're working with somebody that doesn't really know where you're headed. And y'all know by now that I have your best interest at heart. I'm going to teach you the easiest way, the best way, and the way it needs to be done, okay? So no matter what you hear from someone else. All right, so now let's look at some of the problems, and then I'll take questions. All right, so after the first fill-ins, did you have number?
37.
37 to 46 and 59 to 66.
Yeah.
Okay, so 59 was probably pretty
Yeah.
easy. Tangent theta, cotangent theta equals 1. One thing I will not allow, and you'll have to certainly, please trust me, like, look at me and go, I know Miss Lazari, she's not mean, okay? I'm not allowing you to have, every now and then, a student that'll make it y over x and x over y, and they'll use those things. You can't do that. You have to use words, and there's a reason for that. You have two choices here, so I'll have to grade what you do. And especially as these get longer, you know, Nazareth might look different from Mia's. Am I okay? Do you want me,
I can say
you want me to wear it? Okay. So what'll happen is I'll just grade the path that you took. So it takes a while for me to grade these, okay? There's only 10 of you, so I'll figure it out. Okay, so person A may do this. They may go, oh, tangent is sine over cosine. And cotangent is cosine over sine. And then like Bryn said, I can cancel. Okay? And if everything cancels, don't you have one left? Like 3 over 3 or something like that?
Yeah, that's what I meant. I guess it's
There's-
like canceling, not
That is
canceling.
fine. That's option 1. Do you see how I didn't mess with this side? You're just showing you're changing it into it. Okay? That would be like if you bought a jigsaw puzzle and you didn't want to make what was on the front cover. Good luck with that, right? I don't think the chances are very high that you could put those pieces together if you're making like, you know, a princess carriage and all of a sudden it's a car, okay? Another person in the room may have done this. Somebody may have said, you know, cotangent is 1 over tangent. That's also on your memo page. You could cancel and say, I did it. So I'll just grade what you thought of, and I'll steer you toward the good things to think of. Listen carefully. There are not many times, but sometimes I go in the wrong direction. It's probably happened to you putting together a puzzle where I put all the red pieces together before I start trying to fit them together. Every now and then I've shoved a red piece over when it should be part of something else, and I have to go, oh, that piece doesn't fit in there. It's not bad just to like go, I'm gonna start over, okay? So don't worry about that. I've had to do it. Has anybody ever, well, yeah, I know you've at least worked crossword puzzles at school.
I love the mini crossword.
I don't even know what that means.
It's like in the morning. There's been like the big crossword's too hard, so they have a mini crossword.
Which is great for your brain, but you've probably filled in a word, like a 5-letter word for suppose that one of your clues in the mini crossword is a 5-letter color. And I guess it wouldn't be there, there would be more here,
Yellow.
okay? Yellow has more than 5. Then
Blue.
you-
Purple.
Let me talk, thank you, there's a lot of them. So you're making my point even better. But suppose you have already, like, the name of a president, and so you figured out it was like Abraham Lincoln. You just put in
Violet.
But you're not letting me talk. Thank you for thinking. We've got violet, green, blah, 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 okay. And we have yellow, which I think has 6, okay.
Violet is 6. Yeah.
Well, she just counted on her fingers. Okay, girls, to get through the silly
Green.
example.
We already said
Black.
that.
White works.
Okay, no, black.
Okay, thank you for playing my game. Okay?
Black is a
So
shade.
what I'm trying to say is then we're working our puzzle and we are gotten like, you know, Honest Abe down there, and then we look at it and we say a color, and I go 1, 2, 3, 4, 5 is a color. Oh, so I think of black, and then I go in and I keep working my crossword puzzle. But this is like I'll be there blank, and I think, oh, I'll be there soon.
Wow.
Okay. Oh well, this is a bad
I was
example.
gonna say back.
I'll be back.
No, but back isn't I'll be there.
See,
I
but
know,
the
so I was
question,
thinking-
that's what I thought she was gonna do.
Okay. So the clue leads you to the word soon, and you're like, oh, well, I did it wrong. Do you see what I mean? It's not bad to start over and go, wait, I know this one's right. I'll be there soon. And so this one must be brown.
I forgot brown was a color.
Okay. But my point is, if I was working the crossword with Kate, I might put in a word, but I want to work in pencil because I may have chosen the wrong word, and I may have to go back and change it based on everything else that's happening. These are like puzzles, okay? And so that can happen to you. So sometimes you go the wrong direction. Your safety net is you put in your safety net is you're using identities from your memo pages, your pieces with a little bit of algebra. Okay, so I'll do a few more examples, but does anybody have one that they would like for me to work?
So you can't do anything to the right hand side.
You cannot move the right hand side. That's me saying, I need you to,
55.
Let's do 65.
I need you to change it into that. We're doing 65. And so I adamantly
have
say
the-
this.
I have-
problem down, I just wrote the solution.
Alright, here's 65.
It's supposed to equal.
It's just a book.
Alright, so this is great. 65 is sine theta
Look at his little face in the corner. It's so weird.
over cosine theta
He's just
plus cosine theta over sine theta equals cosecant secant. And right now you're trusting me or the authors of the book or the authors of a worksheet that we already have a window into what's coming in your life. And this is what we need from that. What if I put this in Desmos in Y1 and this in Y2? You saw me do that to introduce the topic. They would be exactly the same, wouldn't they?
Yes.
Remember how I put in sine over cosine and hit graph and y'all were like, oh, that's tangent.
Yeah.
Okay? All right, so a couple of things, window into what I've been saying. You might go the wrong direction. That means just stop and go in another direction. I had to change black to brown, okay? I'm real excited when I see this problem. I'm writing it on my sheet of paper and I go, oh, I know these. This is tangent plus cotangent. But that doesn't get me anywhere, does it? Hang on just a second, Mia, okay? Because I just want to use this as a real teaching moment before I get the answer. Look at those words over there, cosecant and secant. The only things you know of them have to do with sine and cosine. You want to keep the word sine and cosine in this problem. I may be still in Mia's thunder, but I really need to teach here, okay? So I hope I'm not. I'll let her say something in a minute. Do y'all see, I don't want to go tan, cotan. Does everybody see if I go tan plus cotan, I'm stuck?
Yeah.
Okay. I look back again and go, wait a minute, I have fractions. How do you add fractions? You get a what? Common denominator. That should be a logical choice of yours. Mia?
That was what I was
I'm sorry. So Mia's gonna get a common denominator. So Mia, what'd you multiply this by?
Sine over sine.
And you show me a word just like Mia's saying it. Very good. Sine over sine. It is super exciting to get them right. And what is Mia gonna multiply this one by?
Cosine.
She's getting a common denominator. Do you see what Mia's doing? She's getting a to add those, don't you need it to say sine, cosine?
Yes.
All right, now, some of you will see what's just happened. Mia already knows what really super cool thing just happened, okay? Let me tell you this too. Because y'all are all so smart. And teaching really intelligent people when they were doing identities, it kind of can work against you sometimes. So let me give you a word of warning. If you don't think really clearly, sometimes it's a little bit easier here because you don't second guess yourself. You're almost all, if not every single one of you, the type of person that could see ahead. Like for instance, this. Like you don't have any doubt what you need to do. You know that 7x, you're going to subtract x. Most of y'all could do all that in your head and say 6x equals negative 7. With identities and with bigger math problems, sometimes you don't know where you're headed. You're just walking and going, I hope this works out. But it's very real world. It can be very unsettling because you're used to being so good at what you do that you know where you're headed. But think about research. Think about gathering data. Think about things a lot of y'all will really do. Think about if you're a realtor and you're going day after day showing people apartments and apartments and apartments. You have no idea which one they're going to pick. You can't predict that. You can predict which ones you need to show them. So girls, I would encourage you to do what's logical. Mia thinks it's logical here to get a common denominator. I'm really teaching you now. I kind of just threw it at you the other day and teaching you. I want to stick with sine and cosine. I don't want to go to tan and cotan. I think I got a better chance with sine and cosine. Okay? Now watch what happens to Mia. On the bottom, both of these are sine, cosine. That's why you did it. You've got to show me every step. What's funny is people get stuck right here, and all of a sudden, voila, this appears out of nowhere. And I go, yeah, I did it in my head. Like, I know exactly what I'm doing. It's cosecant, secant. Let's move on. You won't talk me into that. You have to show me every step because you already know the answer. All right, so Mia, what does this give me?
Sine squared
Sine squared theta. And what does this one give me?
plus cosine
And it
squared
starts to grow into things that you do know. What is sine squared plus cosine squared? 1. So you have 1 over sine theta cosine theta. So do you see how it's growing? Now always keep an eye on your prize. Keep an eye on the front of your box, which is right here, cosecant theta, secant theta. That's what we're wanting. I feel super good about it because now Mia's gotten us this little scrunched up thing. All right, before I would let you here go cosecant theta, secant theta. I would let you say it right now. But let's talk about why I'm able to do that. Cosecant theta times secant theta. Would you agree that 1/3 times 1/4 is just 1/12?
Yeah.
Okay? So this right here, what's 1 over sine times 1 over cosine?
1 over sine cosine. Yeah.
All right, so do you see how I can call it secant, cosecant, secant?
Yeah.
Okay, if you get there, I expect you to know that's 1 over, because it's multiplied, okay? So you got that, man. It's so exciting when you get these. And the good news is you'll know when you get them. I think they're so fun. All right, so what made me react there was a common denominator. That was key. Other questions? Ones that you really tried? I think when you look in the back of the book, it says something like answers may vary, and it's not very helpful.
Can we do 63?
We're doing 63. All right, so 63. All right, so 63 is 1 plus cosine, 1 minus cosine. And we're told that that's supposed to be sine squared. Okay. One thing I look through is sometimes, not always, depends on what's on the other side. A lot of times I like to change all of my words over to sine and cosine. If Mia and I had started that last problem with this, I could have started that last problem right here. I might do that on a test or a quiz, okay? Well, that looks frightening, okay? But with secant and cosecant, do y'all see it makes sense for me to change to sines and cosines? So I would then stop and change this to sine over cosine and that to cosine over sine and go forward, okay? You don't always want to do that, but that's a good idea. Sorry, I'm saying more than I need to on this problem, and a lot of y'all are sitting there going, why is she talking so much about this problem? But I just want to say that. But it's already all in terms of sine and cosine. And remember, you can't change this side anyway. You're stuck with that. So I don't really have anything to do to it, other than what somebody said earlier today. What's your instinct?
Foil.
Foil. All right, so that gives me 1 minus cosine theta plus cosine theta minus cosine squared theta. It's a great question, Kate. Okay. What happens to your cosines in the middle?
They cancel out.
They cancel out. And so Kate is left with 1 minus cosine squared theta. Well, on your memo page, you have this. Sine squared plus cosine squared equals 1. So if I give you that math fact, what is 1 minus cosine squared?
Sine squared.
So that's sine squared, done. So when I give you these math facts, like there's one on your memo page like this. So girls, if you see secant squared minus tangent squared, that would equal 1. Okay, you can rearrange the addition ones to fit. You'll get used to it. All right, so Kate, sounds like you knew what you were doing there, just how to finish, okay? Any other questions off of that? Okay, did I give y'all this worksheet the other day?
I don't think so.
I hope I brought some with me. Maybe I was just gonna post it. Oh, maybe I was just gonna post it. Okay, so I'll post the worksheet. I'll attach it to assignments. So I'm gonna work a few off the worksheet. So before you start your homework, by the way, there are I really didn't give this to y'all. There's 17 questions, and I hadn't decided what I'm gonna give you yet. So don't go do all 17 on the attachment. Read the assignment tab first, okay? I'm gonna do number 5. No, first I'm gonna do number 4. Number 4 is cosecant theta over secant theta equals tangent theta. Have your memo page out in case you feel like you need to look at it. And remember, these are on the video. So if I will assign you number 4. If you can't work it, you can watch the video.
What is that? Sine?
Cosecant theta over secant theta, okay? What's one thing I said is really good to do? Change them over to sine and cosine. So cosecant's 1 over sine, and secant's 1 over cosine. That's my first step. I'm not even writing down the other side because I know that's what I want to change it into. Y'all call this keep change flip, I think? So instead of dividing by a fraction, I multiply by the reciprocal. It's like what I was telling Kate and what Mia did. Wouldn't that be my next logical step anyway? I mean, that's what I would want to do, is cosine theta over 1. Which gives me 1 times cosine theta on the top and 1 times sine theta on the bottom.
And that gives you 10.
And that gives you, oh gosh.
Tan.
I'm sorry, it didn't say that on the sheet, I promise. Over here it said cotangent theta.
Oh, cotangent.
I copied it down wrong. It really says cotan, but you'll see when I load the sheet. I was going toward cotan.
And that gives you 10.
All right, girls, listen. If you type that into your calculator, you'd see a cotan graph like this, where it starts like that and goes, okay? I think you're starting to believe me. I sure hope you maybe believe me from the beginning. This is going to be far easier to work with than that, okay?
Should that be 10?
No, I copied it down wrong off my sheet. My sheet on number 4 said equals cotangent theta. Oh. Hello, equals cotangent theta. That's what it said on the sheet. I copied it down wrong. And what's cosine over sine? Is cotangent. So we're done. Hey girls, don't stop there. I'll count off and you'll be upset, okay? Let me tell you why in years of grading, all right? If you stop here, I've sometimes called people over to my desk and gone, why'd you stop there? And hoping they're gonna say, because I knew that was cotangent. Do you know what they say sometimes? Because I was stuck.
Oh.
And they think they're like not getting anywhere with it, or they don't know their identities very well. They're like, oh, I tried all this stuff and I didn't get there. And so they're not finished with the problem. So no mental. You've got to show me that you know. And every step up there. Let's do another one. Let's do number 6. This is number 6 and we'll end with this. All right, number 6, which you don't have, but I will attach it. Number 6 is secant squared theta minus 1 over tangent theta equals little measly tangent theta. I'd want to go, yeah, I'd want to know that. Secant squared. Do you have it anywhere on your memo page?
Yeah. Well, no.
You're looking.
Equals tan squared theta plus 1.
All right, so Kate has found her secant squared
Oh,
is equal to tangent squared theta plus 1. Did everybody see a secant squared on your memo page?
yes.
Well, what's secant squared minus 1?
Tangent squared.
So, Bran, we can go tangent squared theta. Since I gave you this fact, you're allowed to know. Oh, well, secant squared minus 1, like your question you asked me. Over the bottom is tangent. And what's tangent squared over tangent is tangent. All right, as we're packing up, I want to say this. This is a great problem to do, actually. I didn't have 6 planned, but it's a great problem to do. And that, did y'all notice I didn't make that 1 over cosine and sine over cosine? You'd have eventually gotten there, but it would have been a harder problem. Why did I not do that? Because I'm used to the words secant and tangent being tied in together. And you'll just get better at knowing that, okay? I will assign some of these problems, so check the assignment page. We probably won't have a memo quiz next class, but I'll say it on the assignment page. Send me cats and dogs and whatever.
One time I was like,
So you just
finish it,
this is
just
third grade.
we were like, you don't need to write
like
equals.
third grade. They were talking about.
Oh, I'm changing this side into that side.
Like until
I just
third
work
grade,
with the
I was like, oh my
left-hand
God, I'm
side.
so scared to do that. And
Until
then
I
dividing-
work
it
with the
was me
left-hand
and my
side until I
sisters.
get what I was told to
Before
get.
you throw it to me, and I was
Okay.
like, were you using letters in your mouth?
Where did you get the word I gave you?
Yeah.
This is there.
Bye.
I like
Spinach.
combat boots that aren't like Doc Martens.
Yeah.
And like the Vince.
Bye, girl.